ठीक है. So when we talk about dipole moment, right, it is the physical parameter which let us know about the polarity of a molecule. ठीक है, right? So I can say that polarity of a polar covalent molecule. When we talk about polar covalent molecule, it means covalent molecule which can have polarity because of difference in electronegativity between the two atoms. So I can say that polarity of the polar compound is measured by a term called dipole moment. As simple as that, right? Now dipole moment is given by charge into distance between them. ठीक है, magnitude of charge into distance between them. ठीक है, right? It is a vector quantity. It is a vector quantity, so we will add it according to vectors. Now when we talk about the direction, because it's a vector quantity, there should be a fixed direction. So the direction of dipole moment in chemistry, mark my word, in chemistry, is from positive or low electronegative atom to high electronegative atom. Means from positive to negative. Okay, from low electronegative atom to high electronegative atom. As simple as that. The unit of dipole moment is debye, right? Debye. Now 1 debye is 10 to the minus 18 ESQ. This is also your CGS unit. Okay, right? Now SI unit is coulomb meter. No, no, no. No, it's not related. Okay, it's not related. When you talk about diamagnetic, paramagnetic, it is about the spin of the electron. Okay, magnetic properties, and this is the electrical property. They are two different things, right? So as I said, the dipole moment or polarity is because of electronegativity difference. Okay, so I can say that if electronegativity difference is more, then polarity will be more and dipole moment will be more. So this is one and most important factor which affect dipole moment. Okay, now as I said, since it's a vector quantity, you cannot add the dipole moment of the molecule, right, algebraically. You have to add them using vector addition. Okay, and we know that the formula for vector addition is this. Got it? Now how can I say that a molecule will have zero dipole moment? So I have told you first, right? And the only thing that you should remember, that any symmetrical molecule having all same bonds, right, have zero dipole moment. As simple as that. Okay, right? For example, if you talk about BeCl2, Cl, Cl, it is symmetrical, so the dipole moment will cancel over each other, right? Or PCl3, Cl, Cl, Cl. Since all the three bonds are same, it will cancel each other. Got it? Right? So Sp, Sp2, Sp3, if we have symmetrical molecules, the dipole moment would be 0. Okay? Right? Now, the dipole moment of lone pair is always away from the central metal atom. Okay? As simple as that. So when you talk about NH3, we have already discussed NH3 and NF3, I guess. In NH3, right, the dipole moment is additive, because it is from H to N, additive, right? So the net dipole moment would be more. But when you talk about NF3, so in NF3, since F is more electronegative than nitrogen, right, it is subtractive because net dipole moment would be away from the dipole moment of this lone pair. So it is less than NH3. We have already discussed this, but still you should know, right? Now, when you talk about pH3, since the electronegativity difference between P and H is very less, it's almost equal. There's no polarity. So the dipole moment will be because of lone pair. As simple as that. Got it? Okay. Now, application of dipole moment. So you have to remember, dipole moment means polarity. That's it. Dipole moment high, polarity high. Polarity high, percentage of ionic character high. Percentage of ionic character high, stronger attraction, more intramolecular force of attraction, more intramolecular force of attraction, then higher boiling point. Got it? You should remember like this. Okay? Now, so the two factors, right, which will be depending on dipole moment. The first is polarity and geometry. Okay? Now, percentage of ionic character. So we know that percentage of ionic character will be more if the dipole moment will be more. So the formula is experimental value of dipole moment by theoretical value of dipole moment into 100. As simple as that. ठीक है? Theoretical value means जो हम लोग formula से निकालते हैं. Experimental value जो कि experiment करके आता है. Okay? Got it? Right? So ये दिया रहेगा अगर तुमको experimental value और theoretical value बस पुट करके निकाल देना है परसेंटेज ऑफ आयनिक कैरेक्टर. ओके, नाउ टेल मी दिस, राइट, दिस इज योर सिस. इफ इन ऑर्गेनिक केमिस्ट्री पढ़ेंगे हम लोग, इफ सी दिस CL are on the same side. ओके, यहाँ पे एक डबल बना लेते हैं, ठीक है, because it is for double bond only, right? So it is same side of this double bond, right? It is called as cis. ठीक है, ऑर्गेनिक में अच्छे से पढ़ना है, अभी बस जान लो. And if it is opposite to each other, Cl, it is called as trans. Now tell me, cis का डायपोल मोमेंट ज्यादा कि ट्रांस का डायपोल मोमेंट ज्यादा है इस केस में? क्या लगता है, सिस का डायपोल मोमेंट ज्यादा कि ट्रांस का डायपोल मोमेंट ज्यादा? बताओ. सिस का, राइट, है ना, बिकॉज सिस का दोनों एडिटिव है, दोनों का सेम डायरेक्शन है, बट ट्रांस का सब्सट्रैक्टिव है एंड इट इज सिमेट्रिकल. सो इसका डायपोल मोमेंट 0 और सिस का नॉन 0, राइट? गॉट इट? ओके, बट अगर एक Cl हो गया और एक CH3 हो गया तो बताओ, देखो ट्रांस में क्या है, ये इधर ये भी इधर, और सिस में ये इधर और ये इधर. अब बताओ, now I just replaced one Cl with one CH3. now in this case cis का ज्यादा कि ट्रांस का ज्यादा? टेल मी. cis or trans? In this case I just replaced one Cl with CH3, ठीक है, and this CH3 is sp3 hybridized and this is sp2. So we know that electronegativity of sp2 is more than sp3. that's why ये ऐसे होगा, अगर किसी को डाउट था तो. ठीक है, क्योंकि मैंने कैसे उस डायरेक्शन में कर दिया जो दोनों कार्बन कार्बन है. इट्स अबाउट द हाइब्रिडाइजेशन. डबल बॉन्ड है, वहां पे 3 बॉन्ड है तो हाइब्रिडेशन sp2 है, वह CH3 में हाइब्रिडेशन sp3 है. एंड हाइब्रिडाइजेशन, राइट, अगर sp2 होता है तो इलेक्ट्रोनेगेटिविटी ज्यादा होता है एज कंपेयर टू sp3. गॉट इट? नाउ इन दिस केस yes or yes, see trans is additive whereas cis is subtractive. so इसका ज्यादा होगा as compared to cis. so you should not remember, याद नहीं करना ऐसा कि cis का ज्यादा होगा ट्रांस का ज्यादा होगा, right? depends on the molecule. got it? कि कौन सा molecule है. now dipole moment is inversely proportional to bond angle, right? ठीक है, obviously, है ना? क्यों बताओ? cos थीटा ना, cos थीटा, राइट, cos थीटा ज्यादा, डायपोल मोमेंट कम. जैसे देखो यहाँ पे 180 कैंसिल ईच अदर, ये ऑलरेडी डिस्कस कर चुके हैं. 120 60 लेस देन 120 एंगल, राइट? सो डायपोल मोमेंट विल बी more in this than this. got it? right? now these are some important orders that you have to figure out and remember. ठीक है, ये तुम लोग एक बार अच्छे से समझ के याद कर लेना, बहुत क्वेश्चन पूछता है. ठीक है, सो आई गेस डायपोल मोमेंट कवर हो गया होगा. ये क्वेश्चंस कर लेना, ये काफी अच्छा क्वेश्चन है बाय द वे, ये काफी अच्छा क्वेश्चन है। और एक और अच्छा क्वेश्चन है जिसका हमको आंसर चाहिए। डायपोल का ऑर्डर CCl4, CHCl3, CH2Cl2 और CH4, इसको ऑर्डर हमको चाहिए। होमवर्क, दिस इज योर होमवर्क। ओके, राइट इट डाउन। CCl4, CHCl3, CH2Cl2 और CH4, order of dipole moment. Okay, now the next is van der Waals force. So we have already studied that van der Waals force is a type of force, right, when the attractive force or the energy between two atoms or molecules is less than 42 kilojoules or between 2 to 16 or 2 to 8, right, बस कम होना चाहिए, है ना। Now it is the attraction between two molecules. तो intermolecular forces बोल रहे हो ना, so that is the intermolecular forces, as simple as that. Now intermolecular forces, right, or van der Waals force is directly proportional to molecular weight, right, or atomic weight, and boiling point is directly proportional to van der Waals forces. ठीक है, ये तुम याद रखना. And it is also inversely proportional to branching. ये भी लिख लो. Inversely proportional to branching. ब्रांचिंग ऑर्गेनिक में समझ में आएगा, इसका ब्रांचिंग का मतलब क्या होता है, ठीक है। और इनवर्सली प्रोपोर्शनल टू सरफेस एरिया, ठीक है, ऑर्गेनिक में समझ में आ गई है। नाउ व्हेन यू टॉक अबाउट van der Waals force, it is force of attraction between two molecules. Now depending on the molecule it can be of different types. So हम लोगों ने ऑलरेडी पढ़ रखा है डाइपोल डाइपोल, ठीक है, which is attraction between two dipoles. Dipole induced dipole, where one molecule is your dipole and second is your non-polar compound which comes in contact, not in contact, right, in field of dipole converted into induced dipole. So this is dipole induced dipole. And third is induced dipole induced dipole. This is also called as London force or dispersion force, and this is inversely proportional to 1 by r to the power 6. ये याद रखना, ठीक है, it is inversely proportional to 1 by r to the power 6, ठीक है, right, that's it. Now hydrogen bond, as I said, hydrogen bond is special case of dipole dipole interaction in which hydrogen should be there. Hydrogen should be attached with fluorine, nitrogen or oxygen, high electronegative atoms, either nitrogen or oxygen or fluorine, high electronegative atoms, right? Now if this hydrogen is in vicinity of, because when you talk about hydrogen and high electronegative atom, F delta minus H delta plus, another H delta plus and F minus. So this is positive, this is negative, and since the electronegative difference between them is very high, the charge developed will be more. So there will be attraction, strong attraction. Now that strong attraction is called as hydrogen bonding, as simple as that. Okay, this strong attraction is your hydrogen bonding. Now I can say that it is directly proportional to electronegativity difference, as simple as that. So you just have to remember this concept, ठीक है, it is directly proportional to electronegativity, बाकी सब उसी से explain हो जाएगा, right? Any issues? Okay, now when you talk about type of hydrogen bonding, so I can say that either it can have, either hydrogen bonding can be between two different molecules, है ना, between two different molecules. This is called as intermolecular. Inter means between two different molecules, okay, right? Inter means between two different molecules. Now intra, I'll just give you example of intra. Now According to the definition, intra, what do you think? It is between same molecule. The example is this. Suppose we have N double bond O, right? And here we have OH. Okay, so this hydrogen will have delta plus, and here delta minus, and here we have delta minus. So this, right? This is your intramolecular. Intra. Got it? Right? सबको समझ में आ रही है चीज? Same molecule में अगर हाइड्रोजन बॉन्डिंग है, then it is your intra. Same molecule. Same molecule. Inter means different molecules. Different molecule. Got it? Now, if the hydrogen bonding will be between same type of molecule, same type of molecule, same type, then it is called as homo-intramolecular. But it is between two different type of molecules, different type. Okay, then it is your hetero-intramolecular. जैसे यहाँ पे HF की जगह पे अगर HCl ले आ जाए, HCl नहीं H2 आ जाए मान लो, राइट, H2O, डेल्टा माइनस डेल्टा प्लस, और फिर यहाँ पे HF है, डेल्टा माइनस डेल्टा प्लस. सो जो ये हाइड्रोजन बॉन्डिंग हुआ, दिस इज योर हेट्रो. गॉट इट? सो बेसिक डिवीजन समझ में आया. व्हाट इज हाइड्रोजन बॉन्डिंग, व्हाट इज इंटरमॉलिक्यूलर, व्हाट इज इंट्रामॉलिक्यूलर, राइट, व्हाट इज होमो इंटरमॉलिक्यूलर, व्हाट इज हेट्रो इंटरमॉलिक्यूलर. सबको इतना समझ में आया तो हाथ चालो. सबको समझ में आया? हाथ चालो. राइट, ठीक है. सो आज इतना ही करते हैं. नेक्स्ट क्लास में we will again start with hydrogen bonding. Next class will be our last teaching class. उसके बाद एक क्लास डाउट सॉल्विंग जिसमें पूरा होमवर्क टिप डिस्कस होगा. उसके बाद वाला क्लास हम लोग पूरा प्रीवियस ईयर डिस्कस करेंगे. ठीक है, राइट? सो प्लीज ट्राई सॉल्विंग all the problems. ठीक है, I hope you understood, and please watch the videos if you didn't get any concept, right? ठीक है, okay, okay, okay. Thank you everyone. Okay, yeah, bye everyone.